Assalamu alaikum wa rahmatullahi wa barakatuh, everyone. So far, so good, right? So in this video, inshallah, we are going to just revise the last steps from the previous video where you download your model, okay, and then making it ready for printing. So basically, guys, the printing steps or whatever you would like to call it, the steps involved into the 3D printing stuff is, first step is designing your model or just downloading your model, like when you download something ready from Thingiverse and just print it. So the process starts by designing your model or downloading your model from any online source. Like this astronaut, I didn't design it. Actually, I just went on Thingiverse, downloaded it, and then print it. So you can change the size, orientation. These things you will have control over, like to resize the model or the object and then have it printed. Another student in my class last year, he designed this F-22 fighter jet. So he was actually following a tutorial he found on YouTube. This is a very famous tutorial, how to design F-22 on Tinkercad, that I recommend you guys, you watch this video, this tutorial, follow it step by step, because it's gonna teach you a lot and you will have more practice using everything on Tinkercad. So I liked it, so we wrote his name and the school logo here, and then we printed it. And actually these grain areas here, they were just painted or colored using our board marker. So it's like blue color over yellow. That's why they look greenish, okay? This astronaut also has been downloaded, or was downloaded from Thingiverse, and then we used the board markers to color it or give it some colors, just to show that the students that they can literally print something in white and then use some colors and give it beautiful colors. So that's basically it. So today we're gonna learn more about the printing process. That actually, after designing your model or downloading your model from the internet, you have to go through this step, which is called slicing. And for this situation, we're gonna use a slicer software. Normally, all 3D printers will come with their specific slicer software that will be given to you like in a CD or maybe a flash drive or a QR code to take you to a website of the company to download the drivers and the slicer software specific for the printer or the company who made the printer. But normally I use the Creality slicer. I love this software so much. The most famous software, and it's open source also, is called Cura. The Creality slicer was built on Cura. Cura is an open source software used for slicing 3D models, and it can be used literally with any type of printers, because actually there is a place where you would add a printer and you can manage the parameters and make this software suitable for your printer, whatever the type of the printer or the make or the brand of the printer. Creality Slicer and Cura, you can actually use both of them with any printer if you know the parameters or the characteristics, properties of your printer, like the printing area and all the instructions needed to be added here. So here, for example, guys, when I downloaded this model from Tinkercad to show you last time, once we opened the file here to see what's inside, it came like this. I didn't change the size or orientation whatsoever. So basically, this is the slicer software. That's called the Creality Slicer, and it's a very famous software built on Cura software. And actually, I like to use this one. It's easy to use, everything is clear for me. It's a straightforward software. I had no issues using Reality Slicer for a long time. I've been using this for like 3 or 4 years now. I had no issues at all. No lagging, nothing, no problems whatsoever. So this is basically it. So here, guys, if you see the printer I'm using, it's called the Creality CR10. And this is the large size printer that has a large printing bed. Okay. So this one has a large printing bed, large printing area or surface. If I change to our school printer, that is called the pen maker. So actually I will need to resize this model back again. I'll now scale it, and there's something called uniform scaling, so that I'll make it smaller than the printing surface or printing bed of our school printer. So because it was larger than it was supposed to be. You see, the house or the villa or my design is larger than what my printer can print. So in this case, you need to resize it. Okay. Some models you need to flip them over or make them like be printed upside down or by the side. So in this case, you can actually, this first icon here is called moving. Okay. And then you can use this one to move this design anywhere on the bed, because sometimes you can actually open multiple files or multiple parts and put them beside each other on the bed, and then you can print all of them together. So you put something here, something here, something here, so that it will be one printing job, and you can print many parts together at the same time. So here, guys, this one called is called the resize, and you can watch the size here. And there is something called uniform scaling. If you uncheck this one, when you scale the house back again, so it will change into a one dimension only. Okay, so without changing the other stuff in relation to or relative to what was done before. So it's very important to check the uniform scaling. That's how you can make everything bigger and keep the same like dimensions for everything. And this is how you can make it uniform. Okay. So you need to change the place. You click here. You need to change the size. You click here, and this is how you can change the orientation. Flip something upside down, flip it over, change the orientation, the direction whatsoever. This is where you can click, and this part is called mirror. So you can mirror this to this direction, mirror some part, mirror it upside down like so. Okay, and like so. The one here is called custom supports, and we're going to talk about this later. And this one is called support blocker, and we're going to talk about it later. But as you can see, guys, in my screen here, I can see the dimensions of my printer. This is the height of the maximum height of the CR10, and this is the maximum bed size of the CR10. If I change back to the school printer, so we said we will need to resize back again, okay, to fit the printing area that the school printer will be able to print this. If you are printing something long or high, you would make sure that the printer can will be able to print it. It should fit here inside this box, or it will just change its shape or color like so, to tell you that you are outside of the allowed printing area. Okay, so I'll stay with the CR10 so that we will have a large view. make this design bigger, and this is how I can explain here. So there will be some settings you have to change before printing, because actually the button here hidden beside my photo, unfortunately, this is called the slice button. Okay. Okay, guys. So I raised my image somehow so that you can see what's behind. So this is called the slice button. So I hope my photo now is not hiding the button here, because this area is very important. So now basically we can just hit slice without changing any settings. Okay. We are printing on the standard quality, the generic PLA, that's the filament type material, okay, and the nozzle size. The nozzle is where the molten plastic is coming from. That's where the hot end of the printing head, okay, and then you can change the size here in case you change the nozzle. So this is actually the standard settings for the Creality CR10, and we can click here actually to change a lot of options. Okay, so but if I change nothing here, that's the standard quality, nothing has changed. So if I hit slice, what will happen here? It will take a little bit of time, and then it will change all this model into layers. Okay, so after slicing, guys, and changing, or chopping this 3D model into layers, the software will tell you how many days or how many hours will it take to print. Like this house, for example, will take 5 days and 5 hours 15 minutes to print, and will consume 951 grams and 318.81 meters. Okay, so that's too much of filament, 951 gram. So that's too much, and that's why we can change some specifications or settings to make this lower than that. So if I click preview, okay, or you can use this button here to click preview, and you will be able to see everything after printing. How will it look like after printing? So as you can see here, it looks so different, right? So if you compare now between this normal view and the preview here, it's totally different, right? Why, guys? Because actually these areas showing in red color, like in these, the belly of the horse, everything that this edge under the roof, even inside the house. If we went inside the house and had a look at the roof from down, this edge of the window, some edges under my photo here are actually have nothing to support them from underneath. And as we explained earlier in the previous video about how 3D printers work, so you should have known that when the printer will come to print this area of the horse, there is nothing underneath. So when the nozzle is here, pushing the molten plastic outside, it will fill down to the floor because there is nothing underneath it. So it's printing on nothing, literally. So the molten plastic or the molten filament will just fill to the floor, and this will ruin the whole printing process. So to solve this problem, guys, we add something called support. We add support. So if you go back to our Tinkercad design, again, here, the belly of the horse, you know that there will be nothing to support this area. And how about the roof? So the best practice, the best advice to do now is to take the same roof, okay, and we can download this alone and the house like this, so that we can put this one on the floor, so it will be needing no support, because actually it's flat downside. The downside is flat, and I can now click D. Okay, I can click D and download these things. I download the house alone, I download the roof alone, and after printing I can stick them together. So let's now try to download this only. So if I go export.stl, I'm sorry, we should have selected only selected 8 shapes. So it's already set into this. So I'll wait for it to download, and then I'll show you the result after that. So this problem happens, guys, because so many areas in your design, they need support. So the printer will basically add extra plastic underneath every single part that needs to be supported while printing. Okay? And the best thing also about the slicer software is that you can literally go back in time and see all the layers while printing. Okay? Like so. Okay? And see them layer by layer, and not only layer by layer. You can actually close this one. Let's save it somewhere to get rid of this icon, but I'll keep it on the desktop. This is something called the G-code file. We can talk about it later, but I can go back in time and see when the printer is printing every single part of it. And you will notice here, guys, that I'll talk to you later about something called the infill density. So how much plastic is being put inside the model, and it's set to 100. So this means every single part of the project or the model will be made in full plastic. So now this is downloaded. Let's go to the downloads folder. I'll close this one now. So I'll go to the downloads folder. My house number 2 is supposed to be the one where we didn't select the roof with. I'll keep the same settings and do the slicing, and then you'll see how much time will drop down. Because you see now, guys, these walls will be printed, and there will be no need for extra plastic to support the roof, because the roof is not here anymore. We can actually download the roof alone. So I'll select this roof, and then I export it only the selected shape, export it into into STL file, and open it alone at the same size. If I'm not gonna change the size, it will stay the same. Or in case you change it, the size of the house here, so you should know how much did you change it, so that you can change this also together with it. Or you can use actually the same design file here. If I just move this somewhere else, and if there is enough space, I can actually open a file, go to the downloads folder, and that's my house 3 is supposed to be the roof, and I can actually print them together if there is enough area. Let's make this one smaller just to show you guys that if this was a little bit smaller, and now we made it like, let's say 80%. We can actually use numbers here to make all of them 80%. So I'll make this also 80%. And that's how you can go back to 80. And then I need to move it, and I can just print them side by side. After printing, I can just put the roof, glue it here. But now, guys, let's slice now. I haven't changed any settings so far, and you'll see how much time, you see? Come on, that's too much. Just by changing one thing, we just moved the roof and put it here side by side with the house. Let's have a preview. Now you see, these walls will need no support at all. zero supports are needed here, right? Only these edges, which are so tiny and small, all these edges that will need support, and then the area or the edge under the window, and then you can easily remove this extra plastic after printing. Okay, and the horse also, horse body will need support. So after printing, you literally will be able to easily remove this extra plastic, because actually it will be fragile. This support plastic or extra support material is so thin and fragile that can easily be removed after printing. So what else can we change, guys? Now we can literally go change the settings here. So instead of 100% density, this gives you very strong printouts or designs. But again, you don't need all this plastic or this strength. I don't need this house to be so strong, because I'm not gonna like use it for, you know, it's just a shape or decor or decoration stuff. So it doesn't need to be really at that, you know, strength or too much plastic inserted inside. So basically, we can just change this. If I go to this print settings, I wish I can make a whole video talking about each one of them one by one, but this is actually, the quality is layer height. So the layer height will be you know, suitable for the thickness or the nozzle opening. Okay, so you keep this as it is. Shell also is like the wall thickness. How thick is the outer wall of everything? Okay, the wall thickness is set to 0.8 millimeters. Now, wall line count. How many lines are in the outer wall of something? So if you are talking about this astronaut here, there will be an outer wall, like the body from outside. Everything that is around the 3D object is called the outer wall. So how many lines should be there? It says 2. Top and bottom thickness is 0.8 millimeters. So if there is a top layer and the bottom layer, how thick should it be? Top thickness, top layers, how many top layers? Don't add layers here. Bottom thickness and the bottom layers whatsoever. The top and bottom patterns are like or concentric or zigzag. You can change these things here. Outer before inner walls. So you can actually flip this. So you make the outer walls first and then the inner walls. You can change this. Fill gaps between walls everywhere, and you can change nowhere or everywhere. And there are lots of options to play with, but actually we keep this also as it is. The most important ones is the infill and also the you know, the support and also the temperature stuff. So the infill, guys, you can actually change the infill density, like let's say 10% infill density. Okay, after changing this to 10%, okay, everything will still look the same, but it will be just take fewer or you know, less filament, because we changed one of the options. We need to slice again, so that the software will be able to calculate how much time and how much material will be used. So you see, now we dropped it down from 1 day to 17 hours, 41 minutes, and we are using now, instead of 900 something grams, we went all the way down to 124 grams. So we're gonna save time and save material, and it still looks exactly the same. Nothing has changed. If you go to the preview, you will be able to see that everything is still as it is, but it's not as dense or strong as it should be or was to be. Okay, so basically the best thing about this software is that it calculates the grams and how many hours, and now you can calculate actually the cost. How much will this model cost me to print. So for example, if I buy the one roll of filament, which is 1 kilogram, for 100 reals, if this one says you will use, so I'll say I'll do the calculation. So simple, like calculating anything normally. So I'll say 1,000 grams divided by 100 reals. So let's say I need to calculate how much is each gram. So basically you'll say the 100 reals divided by the 1,000 grams. So 0.1 reals for each 1 gram. So now if this one will use 124 grams, so I can multiply now this number by the 124. So this whole model will cost me 12.5 or 0.44 reals. Okay, so this is basically how you can do the calculation. So now if I'm printing something for somebody or like to sell it, now I can calculate the cost and the profit. I can say I will add like 3 times the price. So for example, this costs you 12 reals. You can sell this for like, let's say 30, 40. So it's up to you to decide how much will you sell it for somebody or print it for someone. And actually, this is how other companies who provide this printing service will calculate everything even before printing. So let's go change something else. So here, this is the most important one. And also let's go to the material, which is the second important one. And actually you can change the printing temperature. So how can I decide the printing temperature? First of all, it depends on the type of filament you're using, and the roll of filament itself will have a sticker stuck to it that tells you the preferred range of temperatures that can go from 180 to 230 maybe. So they will give you the supported or the recommended printing temperature. So you can change it from here. And sometimes when I'm printing in a air-conditioned room like this, I'll take the ambient, that's what we call ambient temperature, or the room temperature surrounding the printer. I'll take this temperature into consideration, because now imagine that the filament is supposed to be used at 200 degrees Celsius. So I can just put it at 220, 230, push it somehow more to compensate for the ambient or the surrounding temperature around the printer, especially the bed temperature, because the bed is a large surface that will be exposed more to the surrounding temperature than the small nozzle or the hot end. So the printing temperature, I can put it at 220. Okay, the printing temperature of initial layers is the same. The bed plate temperature is like set to 70. And actually, I highly recommend that you do the try and error here, because you don't know will your model stick to the floor or not. In case you are using a glass floor like the printer we have here at school, or the Creality CR10 printers, they also have a glass floor, which is somehow difficult to get your models stuck to it. So basically, all you need to do is to make the temperature suitable. It's not that high, and it's not low. If it's lower than it should be, so your model will not stick well or make this, suction layer between the glass bed and the first layer of your model. Those should be vacuum. Vacuum. There is zero air, so that this alone can make your model stick to the bed. After printing, you let it cool down. After it cools down, the model will just come out by itself. Just a little bit of motion or movement or you sometimes need to use a spatula or a very thin knife to remove it from the bed, but it will come easily because the glass will shrink after cooling down, and the model will just pop up by itself. This is where you can change the bed temperature to get good adhesion. We call it the bed adhesion. So you make your model stick well to the build plate or the printing blade. So the flow or the speed is at 100. Okay. The speed of the printing speed, we print actually 50 millimeters per second, but you can make it faster using the knob on the printer itself. The travel is something called retraction. We're going to explain these things later, inshallah, when we are talking about the printer in detail. So retraction means to take the printing thread or the printing filament backward when the nozzle is moving from one area to another. So it will, the thread itself will be pushed backward to avoid having extra plastic leaking or the leakage that you can see sometimes in some prints, like extra plastic coming everywhere. So the retraction distance also, that's set to default, so you don't need to change this thing. The cooling also is enabled. And let's now talk about the support. So we talked about the support, and it's set now to be added everywhere. And you can actually change this or uncheck this one and do the slicing back again and see how much time and filament will be consumed. But you're gonna risk having some areas, some leakage might happen in some areas if you don't give them support, especially this horse body. Because now if we go back to see how will the printer print this part, you see that the part which is the first layers of the belly of the horse, there is nothing underneath them. Literally the printer or the filament, the nozzle will come here in this place while printing, and there will be nothing underneath. So the plastic will fill to the floor. You see? Right? We have seen the whole layer being printed now. And when the printer or the nozzle will come to this area to print these first layers of the belly of the horse, there will be nothing underneath to support it. See, guys? So basically, literally, this plastic will fill to the floor. And you will never get the horse printed well at all. What are the other areas here also? So like let's say, maybe the window edge, the edge underneath the window. But this can go well, actually. You see that we have already a gap between the window and the wall. That's why I told you guys, try to make sure on Tinkercad that everything is stuck well together, because after printing, actually this window will fill down to the floor. You see? Number one, there is nothing underneath, no support at all. And the second thing is not even stuck to the house. This is a problem and a mistake that we did on Tinkercad. If we go back to the design on Tinkercad, let's make sure, is this correct? Yes, guys. We have a gap, a large gap between the window and the house. And actually we needed to make this, we were supposed to make this one much thicker. You can actually make it as thick as you would like, but they were not actually stuck together. So now we corrected this problem. We can download this house again and do the slicing work back again. Okay, so basically, guys, these are the most important things. Build plate adhesion, don't play with these things, but literally this will control these lines that are coming out around your 3D model on the bed, just to protect it from like having dust or sand moving underneath. So it's just drawing a border around it. So the other things are actually not important, because actually, for example, the dual extruder is not supported by our CR10 printer that we are actually working with now. So dual extrusion is basically you have two extruders, and each one of them has a different color of filament that you can do print the same model but using two different colors and so our printer, the CR10 that we are actually now on, doesn't support dual extrusion anyway. So that's basically it, guys. So after you do the settings, actually we will add support, of course. So once you finish, you're done with all the settings, you hit slice. What you will get after slicing again is the time. How much time will it take? How much filament will it take? And then you can have a preview of the whole printing process, and then you save something called the G-code file to a file or a memory card. So the memory card of the printer is actually looks like this. That's size, exactly like the memory card of the smart cameras or digital cameras. They use the same large one. So I should insert this into my laptop. Okay, it will pop up now to show me the files inside the memory card. I hope so. Yeah, now it popped up automatically. These were the old files that were on the memory card. So if I go back to the slicer software, if I just go to change anything, I'll just uncheck the support so that we will go slice again. Okay, and add the support again so that I'll slice again, and then I'm doing this just to show you if you have a memory card inserted into your laptop, so it will show you save to removable. So now I saved this file on the memory card, or I can actually select here and save to file or upload to the cloud. In case I say save to file, so now it will take me, I can save it on the desktop, and I'll call this the My House G-code. Okay, so we saved it in two places now. The first one is on the memory card. The second one is on the desktop. Okay, actually you don't need to save it somewhere on your PC. It's just the memory card because the printer needs this G-code file to print. So in the next time, inshallah, next video, I'll show you what you are supposed to do with these files or the memory card. Basically, you just eject the memory card. Okay, you take it out of your laptop or PC. Okay, and then we will have to insert it on the 3D printer and start printing from the 3D printer itself. Because I told you before, guys, that 3D printers are standalone devices. They can take days and hours to print something. So that's why they don't need a laptop or a computer to be connected to them all the time. You have seen this because once we sliced this at 100% infill density, it told us that it needs 5 days to print. So in case I would like to print something that takes 5 or 6 days, am I supposed to keep my laptop connected all this time to the printer? This is illogical, of course. This is insane. That's why they made the 3D printers standalone devices. There is a place where you plug in this memory card, and then there is a screen on the 3D printer, and there is a button or a knob that you can go navigate inside the memory card, select the file that you would like to print, and start printing from the printer itself. And it will keep doing this for like the 5 days, 5 hours, whatsoever. So you don't need the laptop anymore. But for the sake of explanation, we saved the same file 2 times, we said. One time on the desktop, another time on the memory card. You are supposed to save it on the memory card already. But to show you what does the G-code file look like, Actually, you can open this with the Creality Slicer. The Slicer software will be able to read the G-code file, try to rebuild the 3D model back again. But in this case, you will have no control over it. It's just like a read-only file. You cannot edit or modify anything. Okay, I'm just waiting for it to load. As you can see, guys, I will be able to have a look at what's inside the G-code file. This is the same file that the printer will read from to print. So I can just go preview, see all the layers and everything being built back again as we go. But you cannot actually now change things to it. So actually, what is a G-code? It's a file. You see, that's 7.95 megabytes. You can actually open this file using the notepad, because actually what's in there is actually instructions for the printer to tell the motors of the printer where to go. And if you count the lines here, okay, you see, we are line 2 million something, okay? Like 2,007,700 or something like that. So that's too much of lines. Actually, this can go bigger or larger depending on the size of your model or the the details in the model and so on. But basically, the G-code file is just instructions for the printer. This is the file where the printer will be reading from all the time while printing. You motor X go to this coordinate, your motor Y will go to this coordinate, and that's the extrusion. You have to push the filament this amount or move this motor to this these numbers of steps, and also we have other instructions for the motors, the X and Y and Z. Every time you finish a layer, you start to start the next layer above it. So this is where you order the Z motor to move one step further so that you will find your model done at the end. So that's it, guys, for the slicing process. And this actually applies to everything you would print, whether it's downloaded from Thingiverse or somewhere else, or you design it yourself on Tinkercad, download it and slice it. So this applies to everything, because actually the printer needs this G-code file for printing. Thank you, guys, and next video, inshallah, I'll explain about the printers themselves and the parts, the names of different parts of the printers. We will learn more, inshallah, and I hope you will do great until next video, inshallah. Bye-bye.